Hello all, myself Mahendra from MTech Robotics and Mobility Systems. In this short video, we will be explaining about our course project along with my teammate Ashutosh Sahu from MTech and Robotics Mobility System. We have chosen our topic as robust handwritten digit recognition using SVM and HOG feature detection. The motivation for this project is to create a CV and ML model that can detect handwritten digits in different languages. Here I have in the screen I am showing some of the different digits that we used. Uh, Here is the Devanagari, here is the Bangla, and here is the Telugu. The digits have been labeled as digit underscore 7D, where 7D represents the digit 7 and D represent the Devanagari, and B for Bangla and T for Telugu respectively. The datasets have been collected from various sources online. The dataset that we collected contains bitmaps and PNG images of the handwritten digits. Now we have used support vector machine as a classifier for our project. The support vector machine are a popular and powerful machine learning algorithm that can be used for a wide range of classification problems, which includes handwritten digit recognition also. They are capable of handling high dimensional data such as images. In this case of digit recognition, each image of a digit can be represented as a vector of a pixel value, resulting in a high dimensional feature space. SVMs can effectively separate data points into different classes by finding the optimal hyperplane that minimizes the margin between the classes. In the case of digit recognition, this means that finding the hyperplane that best separates the different digits. Before the data is fed into the model, we have to pre-process the images. The pre-processing steps include, but not limited to, resizing the image to 32 cross 32 bit image, then converting the image into grayscale, normalizing the pixel values between 0 and 1, reshaping the images into NumPy 1D array. Afterwards, we will extract the HOG features. HOG is a very efficient feature descriptor for handwritten digit recognition, which is stable on illumination variation as it is a gradient based descriptor. The HOG descriptors work by dividing an image into small overlapping cells and then computing the histogram of gradient orientation within each cell. The HOG features captures information about the direction and strength of edges and other feature within the image. This descriptor is typically combined with the machine learning algorithm such as support vector machine to classify the images based on the presence or absence of a particular feature. Now my friend Ashutosh will explain about the custom dataset and results that we got from the SVM training.
Hello everyone, I am Ashutosh Sahu. Now I will be explaining about the training process and the experimental results that we got from our custom dataset. For the training purposes, we have used the data of the digits available online from Kaggle and CMatterD as explained earlier. Here is the source code for the training process. Now in this code you can see first we have to import the necessary libraries. Then we have to load the digits. These are the directories where the digits are stored. Now in the directories, the digits are unlabeled. So to label the digits with their corresponding labels, we have used these functions. This will provide the labels for both the training images and the test images. After loading the images, we have to pre-process them. We are following the same pre-processing stages as explained earlier. Now, the images are pre-processed and now we can use the machine learning model, which here is the linear SVM for training purposes. Let me show the results that we got. And this is the result that we got after training. Here in the confusion matrix, you can see that the heat map for most of the digit is darker in color, which shows that the model was able to correctly classify or identify the digits as available in the data set. Now talking about accuracy, here you can see the accuracy of our model. and the precision, recall, and also the F1 score. These are very high, which tells us that our model was able to learn those digits at a very good rate. Now, after training on the datasets available online, we have also created our own custom datasets. These are the broad categories in which we have created those datasets. Now, let me show some of the digits under those categories. Here are the handcrafted images. These are the digits which are simply written on a white sheet of paper. Here are the digits that were written on a crumpled paper. And in this dataset, we have tried to introduce some noise. And we have introduced the noise in the form of some random lines drawn over the image. Now, this dataset takes into consideration that every individual has their own writing pressures. These are the affine transformed digits which are simply rotated by some random angles. In this dataset, each digit is rotated by some random angle. And this is the last dataset which contains the digits whose pictures are taken under very low light conditions. Now let me show the results that we got on our custom dataset. Here is the source file that will use our dataset and test the already trained SVM model. Now let me run this file. This myTest data contains the digits that were written on simple sheet of white paper. Here you can see the results that we got. The file name suggests us that this is the ground truth or the correct label of the digit, and this predicted label is the label predicted by our machine learning model. Here you can see that the model was able to correctly classify most of the digits. The accuracy we got here is about 80%. Let me run this file again and show the results obtained on digits written on crumbled sheet of paper. Here you can see that it was harder for the model to correctly classify those digits because the crumbled sheet of paper produced some noise, and it became difficult for the model to do correct classification. The accuracy we got for this dataset is about 70%. The next dataset contains the digits on which some random lines are drawn to introduce some noise. Here are the results that we got on this type of dataset. Here you can see that there are more number of misclassification as compared to the digits that were written on simple sheet of paper. The reason simply is that there are some noise that are added to the data, and it becomes harder for the SVM classifier to linearly separate those digits. This dataset labeled my rotated digits contain the digits which are rotated at some random angles. Now let me run this file. Here you can see that most of the digits were misclassified. The reason being that we have used HOG features, and HOG features are not rotation invariant. So it was expected for the model to have poor performance. Now let me show the results that we got on the digits which were written with very thin line. As here you can see that most of the digits were misclassified because the model was trained on digits which had considerable thickness. When we provided the data with digits having very thin thickness, the model failed to show good performance. Now to improve this performance, we can dilate those thin digits to have some larger thickness. Now this is done in some another source file. Here we have used a function which is an inbuilt function in the OpenCV library known as cv2.erode. Now this function will increase the thickness of the digits that we were using in this dataset. Now let me show the results that we got. Now you can compare that most of the digits are now correctly classified. It was seen that the accuracy without using the erode function was about 20%, and after dilating using the erode function we got an accuracy of about 70%. Now let me show the results that we got on the digits that were taken under low light. Now in the initial run, we will run the file without any additional pre-processing. Now here is the result that we get. Now here you can see that the digit 1 was correctly classified. Same goes for the digit 5, 6 and 7 and 8. The accuracy is about 50%. Now we try to improve this accuracy by adding some additional pre-processing techniques. The pre-processing techniques that we used are the Gaussian blur, the histogram equalization and the CLA-HE method. Now let me show the results for each pre-processing technique. Here is the result for the Gaussian blur. Here you can see that Here you can see only 5 digits were correctly classified and the accuracy is still same. Now let me try some other technique. I am sorry for this error. Let me close this line and rerun the file again. Now you can see the results. The digits 5 was correctly classified, 6 was correctly classified, and all other were misclassified. This tells us that the PLAHE method, sorry, the histogram equalization method that we used was not effective in improving the accuracy of the model. Now let's test for the last method, which is the CLA-HE method. Here again you can see that the CLA-HE method was also not effective in improving the performance of the SVM model. The reason for such low accuracy even after applying some additional pre-processing technique is the fact that the images were taken under low light. Because of low light, the SVM model was not able to extract meaningful features out of them. Now in conclusion, we can conclude the two following things. The conclusion is that the model was robust enough to categorize the digits under 4 categories that we tested, but was not good enough for the affine transform images and also those images which were taken under low light. And thank you for watching this video.